Yo, hello everyone, welcome back to another today's video. And in today's video we're going to be continuing the complex numbers like we introduced. Now it's the second video. In today's video we're going to be talking about the complex plane. Now you might have seen, like, when you graph normal numbers using real numbers, you have like a x-axis and a y-axis. It's the same thing here, but here this is the imaginary section and this is the real section. So if you plot it, like for example, if I have to let's say I have to plot the number 3 plus 4i. Okay, so I have to plot the number 3 plus 4i. So look, it's in this section because it's positive. So look, this is the 3, this is the 4i. So it'll be like here. This is the point where you mark it. I'm just gonna put this in yellow. 3, like, you can do this for like any number. Here, you can plot this here, 3 and 4i. This will be just be. This is 3 plus 4i. Okay. Now we can do the same thing for every number. Now we can do the same thing for negative numbers. So suppose we have to plot. We have to plot. Like, let's say we have to plot 5 minus 3i. So look, this is the 5, this is the minus 3i. So you have to put it here. Okay, here. Now just match it up here. 5 and minus 3i here, and this will be known as, this is 5 minus 3i. Okay, and this is known as 5 minus 3i. Okay, and the same way, let's have one more example. I suppose we want to plot minus 4 minus 4i. So look here, plot it here, minus 4. Okay, I'll erase that. Yeah, like the dot was somewhere here. Okay, and then put it here. This will be 4 minus, this will be what? This will be 4, no, sorry, minus 4. Minus 4. Yeah. So these are like examples of plotting it. Okay, this was just a basic representation to you. Okay, so now let's do something here. It's like, suppose now these are the basic ways to plot. Okay, any complex number, like we can plot like 3 plus 4, negative numbers, negative real numbers, negative imaginary numbers. We can plot positive real numbers, positive imaginaries, positive real numbers, negative imaginary numbers, negative, and stuff like that. And we can plot any sign because here all the signs are mentioned. Okay? So like, suppose, oh yeah, one more. Suppose we want to plot minus 4 plus 2i. Here. We have plotted it. like the dot. Anyway, the dot was somewhere, I guess here. Yeah, good. I mean, since I'm doing it on a whiteboard, it's not exactly to scale, because this is digitally. But if you're doing this on a paper in school, make sure to do it legally. Okay, this is just to show you. Okay, so this is the basics of the complex plane. But now there are some more things we can do here. Right, for example, okay, so this is all about the complex plane. Okay, so now that we've done this, okay, yeah, okay, now we're gonna move on to our next topic. Okay, so let me just erase all this. Okay, so now that was the basics of the complex plane. Like, you can plot it when you're normally just like when you normally plot real numbers, you can also plot complex numbers. Okay, and also if you're plotting something like if you're plotting something like I plus 0, you can write it as I plus 0, and then you can just plot it. Like, if you're plotting a single imaginary number, it'll just be that number. Okay, so now the next topic we're going to be going through is let's see, and like, if you have to plot something like 5, you can write it as 5 plus 0 I, and it will just be there. And like, when you're plotting individual things, like, for example, I have to show something. Okay, wait, hold on. Like, suppose I'll just make this very quickly. Suppose you have to plot something. Okay, I'll just make this like whatever this is, like this is 4i, 3i, 2i. Okay, for like, and this is I, and this is a negative I, negative 2i, and negative 3i, negative 4i, and negative 5i. Okay, and these are the numbers. Okay, and this is the origin. Okay, and these are the numbers we have made. Suppose 1, 2, 3, 4, 5, 6, and this is negative 1, negative 2, negative 3. No, I'm just making a rough sketch, because I just have to show something. It's not to scale. Okay, so look, like, suppose we have to plot I, simply I. Then this will be I. Like, this is just I. It'll be just like this. Or you know what, you can, like, if you have to plot something like if you have to plot a number like if you have to plot something like minus 2i, but it's just a single imaginary number, we'll only write the dot where it is. Okay, if you have to plot minus 4, just put minus 4, but usually we don't do that because we already have another type of plane for real numbers. But I was just showing you, like, that you can do that. Okay, so yeah, that's what you can do. Like, because anything I after 0 gives nothing, and 0 is the origin. You can't put like you can't mark on the origin, right? So like, it'll get confusing. So you just have to mark it, just put a dot there, that's all. Okay, cool. Now the next topic we're going to talk about is modulus, aka absolute value of complex numbers. Okay, next topic is this. So now we're going to talk about the modulus. Like for example, there's a general rule, like we know that the absolute value of any real number, like this is your basic knowledge, a yeah, okay, like if we have anything inside here, okay, the absolute, like if you have anything like plus minus a whatever, this will always be a. Like if a is a real number, yeah, this is for real numbers, but for complex it's different. Like let's assume that we have something like z is equal to a. We'll do some examples, don't worry. So the general rule is that the absolute value of z is equal to the square root of a squared plus b squared. Okay, like it's not like normally when you normally when you take the absolute value, you don't write it like this, but that's the thing, because complex numbers are different. Okay, so I'll give an example. Okay, like suppose a is something like, suppose a is 3 and b is 4. Okay, 4. Okay, so absolute value of z would be, it would be 3 squared plus 4 squared, and then if we were to simplify this, we would get something like this. The square root of 3 is 9, the square root of 4 is 16. This will be 9, I guess 5, right? Will be 5. Okay, but there are some cases when it won't be a perfect square, like it won't be a perfect square root. For example, if I say if I get something like this here, if I get something like this, 7, 7 plus 6i. Okay, so the absolute value of z would be the square root of 7 squared plus 6 squared. Okay, yeah, so then now we get that the absolute value of z is equal to hold on, 7 squared is 49, 36, 49, 69, 79. We'll get the square root of 85, right? But this is not perfect, so usually we can use prime factorization or something, but otherwise we'll just leave the answer like that. So yeah, that's that. Okay, Okay, now let's try to, now we're gonna do something. Now we're gonna be taking abs. So yeah, the modulus is also known as absolute value. Like if you have to find the modulus of something, of any complex number, you have to write like that. Taking the absolute value of real numbers in the complex form. Of complex numbers. So you know some identities, like a squared minus b squared. Is a squared plus b squared? No, no. A squared minus b squared is a plus b into a minus b. Yeah. But there's another factorization. Have you ever thought of factorizing something like a squared plus b squared? Yeah. So if you factor this, you actually get a plus bi into a minus bi. This is the general rule of factorizing. Okay, so that's the general rule. Okay, like if you have to factor like something like this, like when you multiply, it's like some like we can verify this, like a times a is a squared minus abi plus abi, that cancels out, and we get plus bi times minus bi. Okay, bi times minus b times minus b is minus, so we get b into minus b minus b squared into I squared, which is negative 1. Negative 1 times negative b squared is equal to plus b squared. So that's how I verify it. Okay, so now, so similarly, if you have something like if you have a to the fourth power, suppose, plus b, it doesn't matter if it's positive or negative, a to the 4 plus b to the 4. Yeah, the sign matters because, see, look, a to the 4 plus b to the 4 and a to the 4 minus b4 and a to the 4 minus b4 are complex. Like they're in the complex number system. Because the thing is, like, you might thinking, okay, the difference, you can start at a squared minus a. Let's go to both of them, okay? Here, if you have something like a 4 plus b to the 4, can we write this as a squared plus b squared? We learned this, right, in the exponents. So now we can write this as a squared plus b. We know the sum of squares is a squared plus b squared. Like, yeah, wait. So in this case, like, yeah, a squared plus b squared I into wait, what the hell? Into a squared minus b squared I. It works because in this case, a and b are a squared and b is b. A is a squared, b is b squared. So this is how you factorize this. And like, this is completely imaginary, okay? But yeah, I'm pretty sure this is the correct factorization. Like, you can test some values for this. This is the correct factorization. Yeah. Yeah, okay. So yeah, b. Okay, wait. So look. Now look, let's discover that a to the 4 minus b to the 4. Like, this was completely imaginary. Yep, that's because it's a sum. So we're gonna derive a general rule after this, okay? So if we have something like this, like if we have a to the 4 minus b to the 4th, we can write this as a squared minus b squared, and then like a squared minus b squared, and if we simplify this, what do you get? Using the sum of squares, this will become a plus b into a minus b into a squared minus b squared. So as you can see, we know these factorizations. Like, this is real and this is complex. So this is half real and half complex. That's factorization. So if we simplify this further, the correct factorization for this case would be, let's just correct this a little bit. This will become a plus bi into a minus bi. Okay, and then here simplify. This will just become a plus b into a minus b. That's like a factorization. A plus b into a minus b, and here a plus b, a plus b into a minus b. Cool. Now we factor this. Okay, so now this is the, so look, we're gonna do have a general rule. This is for complex number. So look, here's the general rule. The general rule is that, yeah. Okay, let's make a general rule. Okay. So a to the 2n plus b to the 2n to the 2n is like a to the 2n plus b to the 2n is like fully complex. It's complex. So we can denote this as c. But on the other hand, if you have something like a to the 2n minus b to the 2n so I'll put in brackets here. A to the 2n b to the 2n is completely complex. Okay, and this, and now something like this will be, so this will be has a half real and half and half this and has to be a positive integer. If it's a fraction, it's gonna be messy. So let's not over that. If it's 0, then like it'll just become a to 0 plus a to 0, just be 1 plus 1. Oh yeah, this is like about factorization. So yeah. So now, yeah, I think this is it. Okay, cool. So let's just run all this. These are all the factorizations for even of this. You can see. Yeah, you can test it out, but it works. Trust me. Okay. So now, where's this? We're gonna do one more topic. Which are bridges. Oh my god, 30 minutes. Okay. So I'm just gonna derive a general rule, like a general rule. This is a general rule. Powers positive integer maxes on this complex. Yeah, because like for example, like if you have something like, now this is an example, if like I cubed is equal to the square root of negative 1 cubed, which is this is basically a complex number, because this time we can't simplify this further. And if we have something like I squared, this will be square root of negative 1 squared, and we know the square of the radical of the square root will just be that, so this will be negative 1. Okay, done. Okay, now if you have something like other video. Okay, sorry. And my dad came. Okay. Anyway, oh yeah. Where was I? Here. Yeah, if you raise this to the 4th power, then this will be I squared times I squared. Since I squared negative 1 times negative 1 is 1. So there are two possibilities. Okay, it could be either 1, or it could be minus 1. Okay? Now I'm gonna wrap it up for today's video, because I think that's a lot to take in. Okay? And yeah, so just keep this in mind. Okay? Yeah, because you know, like, yeah. So I hope you take a screenshot of that. Okay. Oh yeah. And suppose, like, if you have to put I to the power of 5, this will be I to the 4 times I. So this will be, I mean, it's still complex, because there's a imaginary real. What is this? This is 1I. Which is I. Right? So basically I to the 5th power. Yeah, I to the 5th power is just I. And basically I. Okay? I mean, if this is negative exponent, I mean, I guess if it's negative it applies, but it'll be a little different. But in this case, we're gonna consider the positive ones because we're talking about odd and even numbers. Okay. Oh my god, the video is so long. No, I gotta end this. I gotta end the video. Okay, bye. It's so long. Oh my god.